This is a video for AQA Further Pure Mathematics. Hyperbolic functions, section 1.3, which is considering the inverse of hyperbolic functions. We know that a graph of an inverse function can be found by a reflection in the line y equals x. So if we want the inverse of y equals sine x, then we simply need to reflect it in the line as shown, and there we get what is called r sine x, arc sine x if you like, or we could write it as sine to the minus 1x. So the inverse of y equals sine x is y equals r sine x, or y equals sine minus 1 of x. We also know that we can write x equals f of y as a reflection of y equals f of x in the line y equals x. So this gives us an algebraic way that we can find an expression for r sine x. I'll illustrate that now and to find the inverse of sine x in an alternative manner. So we can say then that if y is equal to r sine x, then sine y must be equal to x. And this means that x must be equal to 1/2 of e to the y minus e to the minus y. Well, we've seen how we solve this sort of equation. If we now multiply by 2, we get 2x is equal to e to the y minus e to the minus y, and we can multiply that by e to the y throughout the whole equation to give us a quadratic in e to the y. So we get e to the 2y, and then we need to subtract 2x e to the y, and then the minus 1 e to the minus y. If we multiply that by e to the y, it becomes just minus 1, and that must be equal to 0. This is a quadratic that we can solve in all sorts of ways, but one way would be to do it by completing the square. So if we can write that as e to the y, we want half of this value, well, half of that value is just minus x. So we have that all squared. We've got to subtract then x squared, and we've got then minus 1 is equal to 0. Rearranging that gives us e to the y minus x all squared is equal to 1 plus x squared. So I can then take the square root and add x to both sides, which means that e to the y must be equal to x plus or minus the square root of 1 plus x squared. Now the inverse of e to the y is a logarithm, so therefore y, and remember y was r sine x, which is where we started off at the top of the page, so y, which is r sine x, must be equal to the natural logarithm of x plus square root of 1 plus x squared. It's not defined for the other root, so we can't have the negative in there. So we've got y, which is r sine x, is equal to the natural logarithm of x plus 1 plus x squared. And there it is, neatly written out with the solution in the way it's normally written, which is log x plus the square root of x squared plus 1. Cosh x can be done in a similar way. Starting off with the fact that y equals r cosh x, we can use the definition then of cosh to say that x is a half e to the y plus e to the minus y, and then it's exactly the same way as before, multiplying by 2, and then rearranging the equation, we get this quadratic, and this time completing the square, we get e to the y minus x all squared, and minus x squared plus 1, so that when we rearrange that, e to the y is x plus or minus the square root of x squared minus 1. So therefore we have that y is log x plus the square root of x squared minus 1, or log x minus the square root of x squared minus 1. But we know that the r cosh x is greater than 0, and therefore we have that r cosh x must be log of x plus root x squared minus 1. So there's our graphs of that with cosh x and r cosh x. Now it's important to note that there is only one value for r cosh, whereas when we solved the equation in an earlier video there were two values. So there's a difference between solving an equation cosh x is equal to some value, which if I illustrate that on a graph, if I've got cosh x equal to 3, which is the video that we looked at earlier, there are two solutions. But there is only one value of r cosh x for any given value of x. Well, in an entirely similar way to the way we've looked at the inverse of cosh and sine, we could do the same thing for tanh to get r tanh x, and it turns out to be a half of log 1 plus x, 1 minus x. So you should either try that yourself or look for the solution to that in your textbooks. Now that's the end of this video. In the next one we'll be looking at identities of hyperbolic functions.